Alright class, we are now on 6.1c, and this is expanding on our chemical equations, but now adding physical states, which I had previously brought up to you. It is very, very important to show physical states. When we start getting even more into depth with chemistry, we need to know what the physical states are. So for many chemical processes, it's important to know not only the identity of the components, but also the phase or the state of the components. Because of this, phase notations are sometimes used in chemical equations, and I won't even say sometimes. Once we use it, we usually keep using it. Honestly, it will help you understand what you're dealing with at times, and because of that, it will actually give you an answer when you're being asked something if you understand how to read the phases. If we wish to indicate that a compound is a solid, we write a parentheses with an S inside, a small s, after the chemical formula. Similarly, we represent liquids with the L and G as a gas. For example, looking at this equation, we can tell us that solid calcium carbonate reacts to form solid calcium oxide plus carbon dioxide gas. And aqueous is something that's in water. Okay, so many reactions involve substances that are dissolved in water. A substance that is dissolved in water is said to be an aqueous solution. We represent this using the symbol AQ in parentheses in the balanced equation. For example, the bubbles in a soft drink result from the reaction of carbonic acid, and that is right here, this H2CO3 in aqueous, to form new compounds, water and carbon dioxide gas. Water is always L. If it's a liquid, if it's an ice, then you change it to what it would be, gas. But if we're talking about liquid water, it's always L. Now, notice how we write the phase symbols for this equation. The reactant, carbonic acid, was dissolved in water, so we write that as aqueous. The result is liquid water and carbon dioxide. We sometimes use equations with phase symbols to represent physical changes, such as changes of state. For example, we could show the water freezing using the equation of H2O liquid to H2O solid. And if it goes to gas, then you would have it to H2O with gas. So now I'm going to show you slides from another one of my courses. So I just realized I didn't take this off. This is from another course, so ignore this part. So this is a summary of everything. This, when a plus in between, as you can see when we show here, that means that these are just two products that have been produced, and it goes on the reactant side as well. So it separates. The plus sign separates two or more formulas. The arrow is reacts to form products. S is solid, L is liquid, G is gas, A is aqueous. Now, when something's heated, you won't always have this triangle on top, and sometimes you will. I don't know if your book's going to show it or not, but you definitely will see it in 24A. So it's just good to keep it in mind, and just know that sometimes when reactants are heated, it doesn't always show. So it depends on what book you're reading and what problem you'll have. Here is another one of my slides. So basically this just sums up by now, though, if you have already looked at 6.1b, most of this will, if not all of it, will make sense. A summary of everything here. To an arrow, what it separates. Reactants are written on the left, products are written on the right. Multiple reactants are separated by a plus sign. So this is me just breaking down things a little bit more to help those of you that this might be really confusing. And why do we need the phase changes? Because here we see a reactant without it, but you really don't know what you're dealing with. And with the phase changes, you can tell exactly what you're dealing with. You might assume that this is water, but it's actually water vapor. That's why when when you make a fire, you don't see the water vapor that's also being produced because it's in a gas. Now here is again the problem that I showed earlier. It's just with I highlighted the phases because and you guys will eventually have to do this, if not by the end of this chapter. I haven't gotten that far yet, but you will be given words and you'll have to put this together, and you'll be given phase changes and you'll have to put that as well. So I'm just going to briefly go through this. Balance the chemical equation when solid iron 4 oxide reacts with hydrogen gas to produce solid iron and water. Notice water, they didn't say what it is, so by default it's just liquid. So usually there's certain things that's a perfect example. If they're not telling you what it is, then the general state is exactly how we know it to be. So again, this is I'm not even going to go through this anymore. I just want to show the steps, but hopefully this makes more sense